Hello, I'm just going to have a go at this paper. It's a predicted paper for this year with all the advanced information, so it's only got the topics on it that have been listed, and it's paper 1 foundation. So no calculator, but let's have a look at what we've got. So we've got the usual rigmarole, and you've got a formula sheet this year, so let's just have a quick look through that. We've got the area of a trapezium here. We've got half of A plus B times H. It also gives you the volume of a prism, and it gives you the two formulas for a circle as well. So it gives you the circumference and the area. If we keep going down, we've also got Pythagoras and trig, so that might come in handy. We've got a really weird formula for compound interest, and we've got another one on probability. So we'll just keep those in mind in case we need to come back and have a look at them. Alright, so I'm just going to crack on through this paper. I'll give you a link, so feel free to have a go yourself. And yeah, off we go. Alright, so question 1. So it says, write down the value of the 3 in the number 3091. Well, just by me saying it, that 3 is worth 3000. So we just want to write that like that. Lovely. Alright then, so question 2, change 1.6 kilometres to metres. Well, you might know that 1 kilometre is 1,000 meters. So 1.6 is going to be 1,600 meters. Okay. All right, question 3, we've got 4 numbers, -7, -2, 2, and 7. And it says write one of these numbers in each box to make a correct calculation. So something plus something else is going to be -5. Well, you've got a negative here, so you've got 2 and 7, so that 7 really is nowhere near this -5. So you've got to have one of these negative numbers at least. If I was on -2, I'd have to take away another 3 to get to -5. So I'm thinking I'm going to start with -7, and then I've just got to add 2, and that'll give me -5. Okay. Next one then, so it says write the following numbers in order of size, start with the smallest number. So there's always this kind of question where you've got a mixture of fractions, decimals and percentages. I always like to make them all into decimals and then compare them. So this first one is already a decimal, so that's absolutely fine. 1/3, you might know this as 0.3 recurring. But if you didn't know that, if you want to just turn a fraction into a decimal, you can just do the divide. So that's 1 divided by 3. So if I just do this quickly, so 3, and then we'll put a decimal point and a few zeros. How many 3's go into 1? It's 0, and you've got 1 left. How many 3's go into 10? Well, 3 3's are 9, so it's 3 with 1 left. And then you'll notice that it just keeps going forever. Alright, so that's where that 0.3 comes from. And you can find any fraction as a decimal doing that. 21%, well that's an easy one, we can just write that as 0.21, and then a quarter, you might know that as 0.25, but again you can use this technique to do that. Alright then, so once you've done that, you can just look at them, and we want to write them in order in the answer. Now make sure when you put them in your answer, you use the original numbers that they've used. Okay, so the smallest one to me looks like 205. Then it's 0.21, but we'll write that as 21%. Then it looks to be 0.25, which is a quarter. Then it's 0.3. And finally, it's going to be a third. Okay. Alright, so number 5, simplify 11c minus 8d plus 5c minus d. Well, we just want to collect like terms. So how many c's have we got? Well, we've got 11 there and 5 there. So altogether we've got 16c. And I'll just change my colour. And then for d, we've got minus 8 and we've got minus, well, that's 1d, isn't it? So if you take away 8 and then you take another one, altogether you've taken away 9. So that is 16c minus 9d, and I'll just pop it in the answer box. Alright, number 6. The first term in a sequence is 3. The term-to-term rule is add 5. And then it asks, is 97 a term in the sequence? Give a reason for your answer. Well, if we look at the sequence, if we start at 3 and we just add in 5 every time, well, the next number would be 8, then it would be 13, then it would be 18, then it would be 23. And if you notice, it's just ending in 3 and 8 every time. So 97 is not going to be in the sequence because it doesn't end in a 3 or an 8. So I'm going to say no, because 97 doesn't end in a 3 or an 8. Okay. Right, number 7. Liam goes to a cafe. Good for him. He buys 3 coffees for £1.60 each, 2 teas for £1.10 each, and 5 cakes for £2.15. Wow. Okay, work out the total amount that Liam spends. All right, well, we're just going to look at everything individually. So a coffee is £1.60 and he buys 3. So I'm just going to do a quick times. So 0 times 3 is 0, 6 times 3 is 18, and 1 times 3 is 3, plus the 1 is 4. So £4.80 on coffee. Let's just keep that in there. Let's just keep things separate with a different colour. So then 2 teas for £1.10. You might just be able to do this straight away, but let's stick with the method. So 0 times 2 is 0, 1 times 2 is 2, and 1 times 2 is 2. So that is teas. And then we've got 5 cakes for £2.15. So we want to times that by 5. 5 times 5 is 25. 1 times 5 is 5, plus 2 is 7. And 2 times 5 is 10. So that's cakes. Alright then, and then finally, we just want to add them up. So we've got £4.80, £2.20, and £10.75. 0 plus 0 plus 5 is 5. 8 plus 2 is 10 plus 7 is 17. 4 plus 2 is 6 plus 1 is 7. And then we've just got 1 there. So altogether it's £17.75. Okay. Alright, so question 8. Let's just zoom out slightly. So question 8 says reflect triangle A in the y-axis. Alright then, well what is the y-axis? Well, I can't draw a straight line using this technology, but the y-axis is that. So that's our mirror. So we just want to reflect A in that. So I always like to kind of pick a vertex and then see how far away it is from the mirror and then keep going the other way. So this is 1. So if I just draw it a bit, 1, 2 away from the mirror. So it needs to be 1, 2 away from the mirror in my reflection. So that's your first, oops. So that's my first kind of vertex there. Then this one is also 2 away. So it wants to be 2 away from the mirror. And then this one is 1, 2, 3, 4 away. So it should be 1, 2, 3, 4 away in the mirror. And then once you've got your things, let's use a different colour so it looks a bit more obvious. Obviously I'd use a ruler if I was in an exam, but it should look a bit like that. Alright, sometimes it might say label it B or something, but it hasn't asked me that, so I'm not going to do it. Alright. Number 9, so there are only blue counters, red counters and yellow counters in a bag. There are twice as many blue counters as yellow counters, and there are 3 times as many red counters as yellow counters. Right, okay. We'll write down the ratio of the blue counters to the red counters to the yellow counters. Alright, so it says there are twice as many blue than yellow. So that's telling me if there's 1 blue, then there's going to be 2 yellow. No, that's the other way around, sorry. There's twice as many blue. Apologies, so let's just rub that out. So for every yellow, there is going to be 2 blue. And then it also says there are 3 times as many red counters as yellow counters. So we can use the same ratio. For every 1 yellow, we're going to get 3 red. Okay, so from yellow to blue to red, it's 1, 2, 3. Now, let's just be careful because it says write down the ratio of blue counters to red counters to yellow. So we just need to make sure this is in the right order. So blue counters is 2, red counters is 3, and counters is 1. Okay, so that's that. Alright, so here is a bar chart showing the scores of 5 students in their maths and English tests. Okay, it says write down 2 things wrong with the graph. Right, well, let's have a look at it then. So normally in this type of question, there's usually something wrong with the numbers going up. So if we have a look, they're going up in 4s. So 0, 4, 8, 12, 16, and well, there's a mistake there. So for some reason, it only goes up 2 there. Okay, so you might say the y-axis goes up in 4s apart from 16 to 18. Okay, so that's an inconsistency in the graph. And then something else wrong. Well, it says here is a bar chart showing the scores of 5 students in their maths and English test. But looking at this graph, I've no idea which one's maths and which is English. So we don't know which bars are maths or English. Okay. Right then, and then part B, we've got a pictogram. So the pictogram gives us information about the number of chocolate bars sold by a shop last week. Alright, so we've got a little key here. It says that 1 whole circle represents 3 chocolate bars. Okay, but then we want to write down one thing that's wrong with this, and well, actually, it's going to be this half bit here because that's going to be 1.5 chocolate bars, which doesn't really make any sense. Yes, because you can't really say, snap a Twix in half, can you? And sell it, so that's no good. So we're going to write down that represents 1.5 chocolate bars sold, which is impossible. Alright then, so question 11. Mr. Sykes wants to buy a calculator for every student in year 11. That's nice of him. There are 104 students in year 11 and each calculator costs £6.5p. So it says work out an estimate for the amount of money Mr. Sykes will spend on calculators. Well, if we're going to make an estimate, we can make life easy for ourselves. So 104 students, we just want to round that up to make something similar. So I've just put an approximately equals. So it's pretty close to 100, which is going to be nice. And 6.05 is approximately equal to 6. So an estimate for the amount of money he spends is going to be 6 times 100, which is 600. Okay. Part B says, is your answer to part A an underestimate or an overestimate? Well, actually, if you look at the roundings, for both of them I've rounded down, haven't I? So I've rounded down the number of students down to 100, and I've rounded down the money from £6.5p to just £6. So this will be an underestimate. So an underestimate because I've rounded down the price and the number of students. Okay. Oops. Spoilers. Right. 12. So last year, Victoria paid 300 for her car insurance. This year, she has to pay 348 for her car insurance. Work out the percentage increase in her car insurance. Well, percentage is all over 100, isn't it? So the way I would think about this is look at whatever the new figure is and divide it by the old figure. So I've got a fraction there, 348 over 300. Now I could do that as a divide, but in my head I want a percentage increase. So if I can make this out of 100, that's going to be good. So what I'm actually going to do is, because I just have to divide by 3, don't I, to get 100. So I can do the same here. Okay, so you might be able to do it just by looking at it, but you can also do bus stop method if you want to. So how many 3's go into 3? It's 1. How many 3's go into 4? It's 1, remainder 1. And how many 3's go into 18? It's 3. So this is, oh sorry, how many 3's go into 18 is 6. So there we go. All right, so this is 116. And then you can tell that because 100 is the whole thing, this is going to be a 16% increase. Okay, so that's just 116 minus 100, 16 to give you that. Okay. Right, number 13. So L equals 9m plus 2n. It says work out the value of L, when m is 3 and n is minus 6. So we just shove it in. So L equals 9 times m, but we know that m is 3, plus 2 times n, which is minus 6. Okay, and then 9 times 3 is 27, and 2 times minus 6 is minus 12. And 27 minus 12 is 15. All right, question 14. 60 students study a language at school. Each student either studies French or German. 36 of the students are boys. 2/3 of the boys study French. 40 students study French, and use this information to complete the frequency tree. Okay, so we know that 60 students study a language, so we can put 60 in this box here. So let's just go through the information that they give us. So it says 36 students are boys. So we can work out the girls by doing 60 minus 36 is 24. So 24 are girls. It says 2/3 of the boys study French. Well, 1/3 of the boys, which is 36, is 12. So 2/3 of 36 is 2 times 12, which is 24. So 2/3 of the boys study French, and that's 24. So then you can look at what's left, and it's 12 for German. And then it says 40 students study French. So again, 40 minus, well, the boys is 24, and that leaves 16 girls studying French. So 16 girls study French, and then you can do the same. So we've got 24 girls, so it's 24 minus 16 gives you 8 girls who study German. And that's the frequency tree completed. All right, number 15. So we've got the heights in centimetres of 15 plants. It says draw an ordered stem and leaf diagram to show this information. All right, so we want to do a little key here. So let's just start with the first number. So you'd write 3 vertical line 5 equals 35 centimetres. Okay, so if we look at the range here, I think the lowest is in the 20s. So we can put 2 here. Then we've got 30s, 40s and 50s. Okay, so we're just going to do them in order. So we're on 20s. How many numbers are in the 20s? I think there's only one, and that is 29, so I could put a 9 there. So if we look at the 30s, I think the lowest in the 30s is 32. So that's that one. There's a 33. There is a 35. And there are 2 38s as well. Okay, great, that's all the 30s. So let's have a look at the 40s. There is a 40. There are 2 41s. There's a 42. There is a 45. There's a 47. And there's a 48. Okay, and then finally the 50s. I've got 52 and 55. And that's it, 3 marks. Thank you very much. Right, 16. Abby runs a distance of 200 metres in 25 seconds. What is her average speed? Well, it's asking for it in metres per second. So if we've got 25 seconds, we want to divide it by 25 to get how many metres in 1 second. So it's 200 divided by 25, which is 8. So that is 8 metres a second. Bonnie runs at an average speed of 4 metres per second for 240 seconds. How many metres does she run? Well, she runs 4 meters every second, and she does it for 240 seconds. So we just want to do 240 times 4, which is 960. Okay, so that's 960 meters. Okay, so Frank needs 150 grams of sugar to make 24 biscuits. He also needs 3 times as much flour as sugar and 2 times as much butter as sugar. Okay, Frank is going to make 60 biscuits. Work out the amount of each ingredient he needs. Okay, so let's start off with the biscuits then. So we're starting off with 24 and we want to get to 60. So what I do with this is I think what times table are these numbers in? So they're in the 2s, they're in the 4s, they're in the 6s, sorry, but we want the highest number, which is 12. They're both in the 12 times table. So what I'm going to do is I'm going to stick that in the middle, and then I've got like a little rule then. So from 24 to 12, let's grab a different colour. So from 24 to 12, I'm dividing by 2, and from 12 to 60, I'm timesing by 5. So I've got my little rule for the proportion there. So let's work out the sugar to start with. So with sugar, we're on 150. So again, let's divide by 2, and we're going to get 75. And then 75 times 5 is going to be 375. So that's the sugar. Okay, and now I can use these rules here to help me. So he needs 3 times as much flour as sugar. So flour is going to be 3 times 375, which is going to be 900, 225. It should be 1125, hopefully. So that's flour. And then butter is 2 times as much as sugar. So butter is going to be 2 times 375, which is 750. Okay, and that's that question. Oops. Okay, so a cylinder has a diameter of 12 centimeters and a height of 11 centimeters. Work out the volume of the cylinder, give your answer in terms of pi. Okay, well, so a cylinder is a prism, so you just need to work out the area of the end of it and then times it by how long it is. So if we look at the area of the circle then, so let's just draw that in a bit like that. So you've got a circle here. Now we've got the diameter is 12 centimeters, but for our formula, which is in the sheet at the beginning, you want the radius, which is going to be half of that, which is 6 centimeters. So the area of the circle at the end, so an area of any circle is pi r squared, which is pi times 6 squared, and 6 squared is 36, so that is 36 pi. So that's that. And then so the volume of the cylinder is just the area of the circle times how long it is. So that is going to be 36 pi times, how long is it? Well, it's 11. Okay, and 36 times 11 is 396, so it's 396 pi. Okay, and that's that. Oops. Alright, the diagram shows a cone with radius 3 and a perpendicular height of 8 centimeters. On the centimeter grid below, draw the plan and side elevation of the cone. Okay, well, a plan is always from above, so it's like a bird's eye view. So if you imagine a cone, if you look at it from above, it's going to look like a circle. Okay, and we've got that the radius is 3, so we simply want to draw a circle of radius 3. So it'd be easier to do this with a compass, but I'm going to just nominate my centre to be that, and then it's going to be 3 away from that in every direction. So this is a strange way to do it. I would use a compass, because I've just drawn the world's worst circle. Looks like it's been stamped on, but that's the plan. Okay, and you might even want to draw in the radius like we know. And then it also wants the side elevation. Well, if we look back at it, now if you look at a cone from the side, it's going to look like a triangle. Hope that makes sense. So if you imagine you're looking at a party hat or an upside down ice cream, whatever you want to think about, from the side it's going to look like a triangle. And so if we think about how wide the triangle is, well, if this is 3, halfway all the way across is going to be 6. Okay, and the height will be the same, which is 8. So we want to draw, it needs to be 6 across. So again, I would use a ruler if I could. I don't think I've got a straight line option here, have I? No. Alright, so you're just going to have to put up with my terrible drawing. So this is going to be 1, 2, 3, 4, 5, 6. And the height is 8. So let's just look at that. It's going to be 1, 2, 3, 4, 5, 6, 7, 8. And then we want to just, with a ruler, of course, is that. Okay, so that is the side elevation. Okay, so use rulers and compasses, not like I've done. Okay. Alright, so number 20, we want to write 240 as a product of its prime factors. Okay, so the first thing I might do is just have a little list of primes in my back pocket. So let's just draw them on the side. So my prime numbers, the first one is 2, then it's 3, 4 is not 1 because it divides by 2, 5 is 1, 6 is not 1, 2 and 3 go into it, and you can just keep going for a bit. But normally I would guess you don't need to know more than up to 11. So we'll just keep them in our back pocket. And then I'll always start off with just seeing if I can half it to start with. Alright, it doesn't matter what you divide it by as long as you just keep going. So we start with 240. I like to half it every time. So divide it by 2, circle it because it's prime, and half of 240 is 120. I can half that again, so I've got another 2 coming out of it, and that's 60. I can half that again, another 2 coming out of it, that's 30. I can half that again, another 2, and then you've got 15. Now at this point I can't divide by 2, so I look back on my list, the next number's 3, and I can divide this by 3. So it's 15 is 3 times 5, which is another prime number, so I'm done. So now it wants you to write it as a product of prime factors, so they want you to do powers. So we start off with 2. Now how many 2's have I got? I've got 4 altogether that I've circled. So this is 2 to the power of 4. Then we've got 1, 3, and we've got 1, 5, like that. And that's the answer. Oops. Alright, so 21, it says work out 3/4 take away 7/10. So you can either, so we want the bottoms to be the same, the denominators, so you can either just times them together, which would get us 40, or if you can find a lower common multiple, that might make your maths easier. So I've noticed that 4 and 10 are in the, well, go into 20. Yeah, so 4 times 5 is 20 and 10 times 2 is 20. So what I'm going to do is I'm going to put them both over 20. Now, if I look at 4, from 4 to 20, I've times by 5. So I want to times 3 by 5, and that's going to give me 3 times 5 is 15. Now, from 10 to 20, I've times by 2. So I want to times 7 by 2 as well, which is 14. Okay, and then 15 take away 14 is 1, and the 20 stays the same. So that is just 1 over 20. Alright, next one. So it says work out 2 1/3 times 3/5. Give your answer as a mixed number in its simplest form. Well, the first thing I want to do is turn this 2 1/3 into a top-heavy fraction. So I just do 2 times the bottom plus the top. So 2 times 3 is 6, plus 1 is 7, so that's 7 over 3. So now we know that's 7 over 3, I can times it by 3 over 5. And all you do is you times the top 2 together to get the top, and the bottom 2 together to get the bottom. So the top is 7 times 3, which is 21, and the bottom is 3 times 5, which is 15. Great. Now I want to simplify this. I've noticed they're both in the 3 times table. So 21 divided by 3 is 7, and 15 divided by 3 is 5. And they also want it as a mixed number. So how many 5s go into 7? 1 with 2 remainder. So that is 1 2/5. Okay. Oops. Sending me an email there. Right, so. Alright, so in a bag, there are only red counters, blue counters, green counters, and yellow counters. The table shows the probabilities that the counter will be green or yellow. The probability that the counter will be red is twice the probability that the counter will be blue. Okay, so let's just write that in for now. So whatever the probability of blue is, let's call it, oops. Okay, let me just refresh. Let me just save this for a sec. And we'll go back to where we were. Okay. Sorry about that. There we go. All right, so if this blue is x, then red, it says the probability is twice, so that's going to be 2x. Okay, so we can figure that out in a minute. There are 21 green counters in the bag. Work out the number of red counters in the bag. Okay, so we need to figure out how many we've got left over. So probabilities add up to 1. So if we just look at green and yellow, that's 0.35 plus 0.2, and that equals 0.55. If we take that away from 1, you're going to be left with 0.45. Okay, now how many x's have we got to split that between? Well, that's 3, isn't it? We've got 2x that are red, and we've got 1x is blue. So 3x is 0.45, and if you divide 0.45 by 3, you get that x is 0.15. Okay, because 45 divided by 3 is 15. Okay, so now I can actually just put these in here now. So that is 0.15, and red is going to be double that. So red is going to be 0.3. Okay, so now it's saying there are 21 green counters in the bag. Okay, so let's just have a little think about that then. So 21 is going to be, let's grab a different colour. So 21 counters. Now if we look at green, that is 35 out of 100. And if we simplify that a little bit, if you divide by 5, you're going to get 7 out of 20. Okay, so what I'm thinking here, well actually let's make this a bit better. So let me rub that out. Let's do a better idea. Okay, so 21 is 35 out of 100. Now we want 30 out of 100. So again, we're looking a bit like the proportion. We're going from 35 to 30. And we're thinking what number is in both of the times tables. And they're both in the 5s, aren't they? Okay, so now I'm thinking, well, 35 to 5, I'm dividing by 7. And 5 to 30, I'm timesing by 6. Okay, so to get this red, which is 0.3, I want to do that. So divide by 7. So let's just do that to start with. So divide by 7, I'm going to get 3. And then times by 6, I'm going to get 18. Okay, so there are 18 red counters. Like that. All right, 23. So here is a graph of y equals 2x plus 6 minus x squared. Okay. Question 1, well, A says write down the turning point of the graph. Okay, so if let's just zoom out a little bit. So the turning point is, let's get a more vibrant colour. The turning point is going to be this bit where it turns. Okay, so we just want to look at where that is. So if I look at this to me is looking like just before 1, so maybe 0.8, something like that. So 0.8 for x, and it looks to be pretty much on 7 for y. So that's going to be 0.8 and 7. Okay, B says, use the graph to find the roots of the equation x squared equals 2x plus 6. Well, if you look at this is very similar to this. Okay, now if we just take away this x squared, onto this side, we're going to get 0 equals 2x plus 6 minus x squared. Okay, and now that's exactly the same. So what we're looking at is we want y to be 0. So all that is, y is 0 is here. So this whole line here is y is 0. Okay, and you're just finding the 2 points where it crosses that line. Okay, so what x's have we got? Well, this first one, so let's just, can we rub that out to make it a bit more? There we go, that's not too bad, is it? Alright, so what x have we got here? Well, you've got 2 here, so this bit here is going to be minus 1. But let's not confuse things. So this to me looks to be about minus 1.6. So my first x is going to be minus 1.6. And the second one, to me, that looks to be about 3.6. Okay. And that's that. Alright. So, next question, 24. So we've got 5 is less than 2y is less than 12, where y is an integer. So an integer is a whole number. So that's a good word to learn if you don't know it. So A says write down all the possible values of y. Okay, so the first thing is we've got 2y. So like we would with solving anything, we just want to half it. So let's just write it out again. So we've got 5 is less than 2y is less than 12. So we just want to half everything. So half of 5 is 2.5. Half of 2y is just y. And half of 12 is 6. Okay, now what are the possible values of y now? It's got to be a whole number. So it's got to be more than 2.5. So the first number it can be is 3. It can definitely be 4. It can also be 5. Now, it cannot be 6 because it's just a less than sign. If there was, I'll just write this with a different colour. If there was an equal sign there like that, if it was less than or equals, then yeah, you'd be able to have 6. But because there isn't, we can't have that. So that's that. Okay, so next question, it says solve 4 is more than 19 minus 3x. Okay, well you can treat this more than sign as an equals and just solve it as normal. Now the first thing that I'm not enjoying is the fact that this is a negative number. So I'm going to move this minus 3x over to this side to make it plus. So we've got 3x plus 4 is more than 19. Next thing I'm going to do is I'm going to take away the 4. Okay, so we end up with 3x is more than, well, 19 take away 4 is 15. And then finally, we just want to divide by 3. And 15 divided by 3 is 5. So our answer is x is more than 5. Okay. Oops. Alright, so number 25. So Dermot has 240 counters. The counters are either red or blue or yellow or green. Alright, 15% of the counters are red, 2/5 of the counters are blue, and the ratio of yellow counters to green counters is 3 to 1. Work out the number of yellow counters Dermot has. Okay, so let's just work out each bit individually. So we want to work out 15% of 240. Well, an easy one to work out is 10%. So 10% of 240 is, well, you just divide it by 10, so it's 24. Now for 15% we need another 5%, but we notice that 5% is half of 10. So half of 24 is 12. So altogether 15% is going to be 36 because that's 24 plus 12. So 15% of 240 is that. So let's write that down. So we've got 36 red. Okay. Now it says 2/5 of the counters are blue. So I probably should use different colours for these, but never mind. So again, we'll find 1/5 first. So 1/5 of 240. If you divide it by 5, you get 48. And we want 2/5. So 2/5 of 240 is double that, which is 96. So we've got 96 blue. Okay. So now we've got yellow and green left. So let's figure out what that actually looks like. So let's use a different colour to add up what we've got. So we've got 36 plus 96 is going to be 132. And to find out how many we've got left, we do 240, take away 132, which is 108. Okay. Now for the ratio, let's grab a different colour. We want to add up the numbers in the ratio. So 3 plus 1 is 4. So there are four parts of the ratio. So I've got 108 left, so I want to do 108 divided by 4, which is 27. So each part of the ratio has 27, and we want the number of yellow counters, so finally I'll use the yellow. We want to times that by 3, because there's 3 in the yellow. So that's just going to be 27 times 3, which is 81. So there's 81 yellow. Alright, so there's a lot to do there, but each step is alright. It's just fractions of an amount, percentages of an amount, and a bit of ratio. Alright, but there's 4 marks, so it's well worth your toil. Alright, 26, here is a cube. Work out the volume of this cube. Give your answer in standard form. Okay, so the volume, you just times base times height times length. So, but with a cube, they're all the same, aren't they? So it's 0.05 times 0.05 times 0.05. Okay. Now the way I do decimals is I ignore the decimal and just times the numbers together first. So 5 times 5 times 5 is 125. And then what I do is I figure out where my decimal point goes. So I've got 125. And what I do is I add up all the digits I see after a decimal point in the question. So I've got 1, 2, 3, 4, 5, 6. Okay, so I want 6 digits after the decimal in my answer. So I've got 3 already, so I'm going to have to stick in 3 zeros to make it 6. Okay, and that's that. Now we want it as standard form. So for standard form, you always do a number times 10 to the power of something, and that number is always between 1 and 10. So where does my decimal point go? Well, if it went here, it'd be 12.5, so I don't want that. So I want it between the 1 and 2 to make it 1.25. So then I know that it's going to be 1.25 times 10 to the power of something. And I just look at how far my decimal's moved. Well, it's gone from there, 1, 2, 3, 4. So it's moved 4. And because it's gone smaller, because it's a very small number, it's going to be minus 4. Because if you times this by 10 to the 4, it'd be like 125,000 or something like that, or 12,000. All right, so that is that. All right, so 27, A, B, C, D, E, F is a hexagon. You've got a load of angles in there, and then it tells you that angle CDE is 2 times the angle BCD. So BCD is this. So if that's X, we're saying that CDE is double that. So again, I'm just using algebra when I don't know what it is. So it says work out the size of angle CDE. Okay, well there's a few things we need to know. The first is how much do all the angles in a hexagon add up to? So what you do is you look at the number of triangles in it, and it's always the number of sides take away 2. But if we just pick a point, so let's pick this E point, and you just draw triangles all from that point like that. Okay, so we get 4 triangles, and so the total is going to be 4 times 180, which is 720. Okay, so we know that all the angles add up to 720. So let's see what we've got already. We've got 1, 2, 1, we've got 1, 4, 4, we've got 1, 2, 9, and we've got 1, 2, 5. So we can definitely add all those up. 1 plus, that's 19, 6, 10, 11, and 5. So they all add up to 519. And now we can take that away from our total. So 720 take away 519 is just going to give you 201. Okay, so again, let's grab a different colour. we've got 3x's all together, yeah, we've got 2 here and we've got 1 there. So 3x is 201. And if you divide by 3, you're going to get that x is 67. Okay, and then it says work out the angle of CDE. Well, remember that's double that. So CDE, well, 2 times 67 is 134. So that is that. Okay. Right, we're not far off the end now, are we? Right, so 28. Liquid A has a density of 1.2 grams per centimetre cubed. 150 centimetre cubed of liquid A is mixed with some of liquid B to make liquid C. Okay. Liquid C has a mass of 220 grams and a density of 1.1 grams per centimetre cubed. Okay. All right then, so it says find the density of liquid B. Right, well I'm just going to think about that for a minute. So density is, now if you don't know the formula, look at the units. Yeah, so it's grams over centimetre cubed. Now grams is mass and centimetre cubed is volume. Okay, so for the density of B, I need to know the mass of it and the volume of it. And at the minute, I don't think I know either, do I? So let's use some of the other information that we've got. So C looks helpful because I've got 2 of them, haven't I? So density of C is 1.1, and that is the mass divided by the volume, which we don't know. So let's just put V and I'll put a little c, the volume of C. That's just my little thing for that. So we can swap these two things to make it easier. So the volume of C is going to be 220 over 1.1. Now, if you have a look at that, I'm seeing 22 and 11. Okay, so 22 divided by 11 is 2. But I've got 220, which adds a 0, and I'm dividing by a tenth less, so there'll be another 0 there. So it'll be 200 altogether. All right. Okay, so I've got the volume is 200. Okay. And that is going to be, because it's volume, centimetre cubed. So that's the volume of C. Now remember, the volume of A, if we look at this, is 150. And you know, volumes just add up, don't they? So that means that the volume of B must just be 50 centimetres cubed to add up to make this 200. Okay, so I'm going to keep that in a square because I'm going to need that in a minute. So I've got the volume. So now I want to figure out the mass. Okay, now the mass again is going to be added up. So we know that liquid C has a mass of 220. So let's just grab a different colour. So we know that mass of C is 220. So we want to figure out the mass of A. Okay. Now again, we can use that the density of A is 1.2, and that is mass, which we don't know, so I'm going to call that mass of A, divided by the volume, which is 150. Okay. And then to solve that, I just want to times that. So mass of A is going to be 1.2 times 150. Which is 180, I think. All right, so you might want to do long multiplication or whatever. 12 times 1500. Yeah, I'm happy with that. Okay. All right, and then so the mass of B, which we're interested in, is just going to be 220 minus 180, which is 40 grams. All right, we're nearly there now. So finally, we use our density equation. So the density of C is going to be the mass, which is 40, over the volume, which is 50. That simplifies to 4 over 5, or 0.8. There we go. All right, so quite a lot going on there, but you're just using the same formula over and over again, which you can guess from the thingies. From the units. All right, so 29 then, it says write down the exact value of sine of 45. Okay, now you can either just learn this, so this is going to be root 2 over 2, but I'm going to show you that there's a way of figuring it out, but by how much they've left you with room, I think they're expecting you to know it. So what you do is you start off with a right angled triangle like that, where these sides are 1. Now, if you think about Pythagoras, this is going to be the square root of 1 squared plus 1 squared, but that's just 1 plus 1, so it's the square root of 2. This is 45. We want sine of it, so you use trigonometry. So is the sine bit. So sine is, well, this is the hypotenuse. If this is the angle, this is opposite, and this is adjacent. So sine of 45 is opposite, which is 1 over hypotenuse, which is root 2. And then what you do then is, because it's over root 2, we don't really like that in maths, so we want to, what you call, rationalise it. So you times the top and the bottom by root 2. Okay, and that'll end up giving you this. But for me, that's a pain in the bum, so you might want to just try and learn the exact values, and that sine of 45 is root 2 over 2. Okay. Right, 30 then. I think this is the last question. So it just says factorise x squared minus 3x minus 18. Okay, well, all I want to do here is figure out two numbers that times to make minus 18 and add to make minus 3. So, oops, let's just rub that out. So I always start with the time, so I'm thinking about 18, what factors go into that. So there's always 1 times 18, 2 times 9, 3 times 6. Now to get minus 18, one of these has got to be a minus. And remember, I'm trying to get to minus 3. So I'm thinking this pair might be good, and because it's a minus, it's going to be the bigger number that's a minus. Okay, so this factorised, we've got 3 and minus 6, that's going to be x plus 3 and x minus 6, like that. Now we want to solve that this is 0 for part B, so we've got x plus 3, x minus 6 equals 0. So what that means is either x plus 3 is 0 or x minus 6 is 0. Well, if x plus 3 is 0, x must be minus 3, because minus 3 plus 3 gives you 0. And if x minus 6 is 0, well, x must be 6, because 6 minus 6 is 0. So your two options are minus 3 and 6. But when you get one like this, where there's just one x, you can just swap the sides of whatever's in there. Swap the signs, sorry, and you'll end up with that. Alright, well, that's the end. So, what's that taken? About 50 minutes. So I'd have 40 minutes more to, I don't know, have a nap or look over my answers. Probably should look over my answers. But that's it. So, hope that was helpful, and I'm hoping to do more videos soon.